Hello and welcome to this video on histograms. In our video that talked about graphical displays, we briefly introduced histograms. At that time, we learned that histograms are a type of graph that looks like this. It allows us to show counts and percents of quantitative variables. I encourage you to rewatch the video with the title Graphical Displays if you feel like reviewing the concept of histograms and other types of graphs. Today, we will learn some properties of histograms and a particular way to construct a histogram. First, let's talk about the skewness of distribution. If a distribution spreads thinly far to one side, it is skewed. In the graph here, it has a long tail pointing towards the left, so it is said to be skewed to the left. On the other hand, when the tail is pointing to the right, the distribution is said to be skewed to the right. Now let's move on to the center of a histogram, namely the median and the mean. We've already introduced the median and the mean in the video of measuring the center of a distribution, so you might want to review that video before we go on. In a histogram, or in fact any distributions, the median divides the area of the graph into two equal halves. Right here, the left side of the median has the same area as the right side. The same goes for this graph too. These two areas are equal. The mean, on the other hand, is affected by the spacing of all values. It corresponds to a line passing through the center of gravity, or the balance point. This means that if you cut a piece of cardboard to have the same shape as this graph, and you want to suspend it on a ceiling with a rope to make the cardboard parallel to the ground, you would need to put a rope around the mean. This way, the cardboard will stay flat and balanced. Now, if we put down the mean and the median at the same time, notice what happens. In a histogram that is skewed to the left, the mean is more towards the tail than the median. Meanwhile, in a histogram that is skewed to the right, the mean is to the right of the median. And this actually makes sense, since we know that the medians are insensitive to extreme values, but the mean can be easily affected by extreme values on the tails of the histograms. Next, we are going to learn one way to construct a histogram with z-scores and percentile rankings. Let's use an example to illustrate that. Suppose we have the percentile rankings of various z-scores of the distribution, and we are asked to construct a histogram for that distribution based on this data. How should we do that? Let's start with labeling. We have seen that we can use relative areas to represent relative frequencies, so labeling the vertical axis is not necessary. And just like what we did when we talked about the empirical rules, we can label the horizontal axis in terms of z-scores. So let's do that. From the chart, we note that 0% of the data is less than the z-score of -2, and 100% of the z-scores are less than +2. This indicates that the entire area should be in between the z-score of -2 and +2. Also, 10 minus 0 is 10, meaning that 10% of the area is in between a z-score of -2 and -1. So let's use a block to represent the 10% of the data. Similarly, 30 minus 10 equals 20%. So 20% of the data is larger than a z-score of -1 and smaller than a z-score of 0. So let's use two blocks to represent the 20% of the data. After that, 70 minus 30 equals 40% of the data is in between 0 and 1, and we use 4 blocks to represent that. 100 minus 70 is 30, so 30% of the data is in between a z-score of 1 and 2. So here are 3 blocks. Finally, we can use a line to construct the histogram, and that's our histogram. Recapping, today we talked about histograms, specifically the properties of the centers of histograms, and how to construct a histogram using z-scores and percentile rankings. And that's all for today. See you in the next video. Bye!